This video is on experimental and theoretical probability. Experimental probability, the ratio of the number of times make that a little darker. So the ratio of the number of times an event occurs to the total number of trials. Theoretical probability is the probability of an event happening based on all possible outcomes. Theoretical probability answers this question, what should happen? So we're going to look at this spinner here that we have with these shapes on it. What is the theoretical probability of a spinner landing on a circle? So we have 1, 2, 3, 4, 5, 6, 7 possible outcomes, and then the circle is 1. So that's going to be 1 out of 7. That's theoretical. What is the theoretical probability of the spinner landing on a heart? So we have 1, 2 hearts. So that's 2 out of 7. What is the theoretical probability of the spinner not landing on a circle or a diamond? So if it's not landing on a circle or a diamond, that's 1, 2, 3. So that leaves 4 because we've got 1, 2, 3, 4. So 4 out of 7 there. All right. Then up here it says to spin the spinner 10 times and complete the table below. So I'm going to spin it right here. It's a little glare on it. I don't know if I can get the glare off it, so I just have to tell you. So spin it once, it landed on a heart. Twice, a diamond. 3 times, a triangle. 3, 4, a diamond. 5, a triangle. 6, a triangle. 7, circle. 8, a plus sign. 9, that's all wrong. 9, a diamond. 10, a circle. So I've spun, let me tilt that up. Okay, so I tilted this spinner 10 times, or spun this spinner 10 times, and got this data right here. Okay, so if we fill that up, the total spins would be 2 out of 10, right? For here, because we spun it 10 times. 3 out of 10. 3 out of 10. 1 out of 10. And 1 out of 10. So the experimental probability here is going to be 1/5 because that can be reduced. 3/10 can't. That one can't. 1/10 and 1/10. So that's the experimental probability is what you get. Theoretical is what you should get. All right. Are there any results in which the theoretical and experimental probabilities are the same? Why or why not? The answers are going to vary based on the spins. So the answers will vary based on the spins. If it ever matches, just note that the theoretical and experimental probabilities matched. Okay. Relative frequency. Relative frequency is the total number of successful attempts divided by the total number of trials. It can be used to make predictions. As the number of trials increase, the relative frequency of an event will approach the theoretical probability. All right, so this spinner has been spun 50 times, and here's what we got. What's the relative frequency? So the relative frequency here is going to be 12 out of 50, but we know that's going to reduce to 6 over 25. 8 over 50, remember it was spun 50 times, and that's going to reduce to 4 out of 25. 13 out of 50, 13's prime, so that's going to stay. 10 out of 50, that's going to simplify to 1/5. And then 7 out of 50 doesn't reduce because 7's prime. So we've got that right there, and then that'll give you, if you divided those, the frequency of them. Most of them on average are going to be about 24%. So if we did this one, it's 24%. All we're doing is dividing. 4 divided by 25 is 16%. 13 divided by 50 is 26%. This has dealing with this column right here. And then 1 divided by 5 is 20%, I believe. Yeah, 20%. And then 7 divided by 50 is 14%. All right, we're not going to spin them 100 times. We may do an activity in class where you do that. And when you spin this, if we spun the spinner 100 times, you would see that the theoretical probability of landing on each number is roughly 20%. That's if we did. So that would say the theoretical, that's what you would expect to get. And we say that because, you know, how many ones, that's 1 out of 5, and that's 20% for each one of them. And if you spun it 100 times, you should be closer, near 20% as well. How can you describe the likelihood of spinning a 5 compared to spinning a 2? They're equal spaces, so they're equal likely events because they're equal. I mean, there's 1 5 and 1 2, so you're going to have an equal amount of chance. Cain is going to spin the same spinner 1,000 times. How can you expect the frequency to change, and what percentage of the total spins could Cain expect to land on 3? He's still, with the theoretical probability, he's still going to have, even as it increases, the relative frequency is going to still approach the theoretical probability. So it's pretty much going to stay the same. The more spins. And the percentage is still going to be around 20%. Abe has 4 $5 bills, 3 10s, and 2 20 bills in his wallet. He reaches in and randomly selects a bill. So I'm going to do this. A 5, a 5. What is the likelihood of selecting a $20 bill as compared to a $5 bill? That's going to be about half as likely because there's only 2 20s and 4 5s. So we're going to put half as likely. And that's why, because there's 4 5s and 2 20s. What event is less likely to occur than selecting a $10 bill? And once again, it's still the 20 because there's less possible chances. And what is the likelihood of Abe selecting either a 5 or a $20 bill as compared to a 10? It's twice as likely. You have 5 more 5s. So twice as likely to select a $5 bill. Or a $20 bill. Because together there's still more than the 10. We'll work on this relative frequency some more with your homework assignment.